Right, now we're going to look at doing all of the trickier equations that you're likely to come across. So this is where the formula triangles will let you down. In actual fact, we can do a bit of simple algebra and we can follow the same two rules we've already met. So when you're rearranging for something, remember, the thing you want to find, it has to be on top and on its own. So it has to be on its own on one side of the equal sign, and it has to be on top, not stuck underneath a fraction. And remember that to rearrange, to get that to happen, you need to move things across the equal sign. So just think, do the opposite. Now, even for more complicated stuff, we can start to apply that same rule. For more complex equations, it becomes a bit tricky to know what order to do things in. And it comes with practice and a little bit of experience. But don't be afraid of a bit of trial and error. Okay, let's look at, for example, potential energy. So this is delta E, or change in E, equals mg delta H. So the delta means change in. Okay, right. So that is all part of the same thing. It's just a symbol that comes in front of a letter. So you can't separate delta out. It's an instruction that's attached to the letter. So let's say we want to rearrange this for any of the letters on the right-hand side. Let's just go for G. So do not do this. You're instantly going to fail. Leave G where it is because it's on top. You just need to get it on its own. What do we need to move? The M and the H. So move them. They're multiplied by, they come divide. Don't put them on top and put the E on the bottom. You've moved the E and you've moved it illegally as well. Leave the E where it is. So what we want to do is move, let's say we're after the G. We want to move the M, so divide by the M. We want to move the H, so divide by the H. Notice that goes on the bottom. We don't want to do something like this. That's not a fraction. That's a high-rise building block. Divide by the M and the H. Just do it together. So take the whole M and the whole delta H bit down. Leave the G behind. So G is change in energy over mass and height. So yes, this is energy divided by mass and also divided by height, but you are, because they're on the bottom of the fraction, multiplying those two things together. Again, a little bit more complex, but it comes with practice. One other little tip, as I've mentioned before, is put some numbers in. What is 2 times 3 times 4? Well, 2 times 3 is 6, times 4 is 24. So if you're rearranging something, those numbers need to make sense. So we've rearranged for the 3, divided by the 2 and the 4. So that's 24 divided by, well, 2 times 4 is 8. Leaves us with 3. I'm not suggesting these are the numbers from the question. These are just made-up numbers that you've put in for mg and h to see what you get. And then you rearrange the numbers the same way you would rearrange the letters, and you can see immediately whether you've done the algebra right or wrong. You can do that with any equation. Okay, let's move on to the next equation, which is the kinetic energy. Probably one you're going to be using more than the gravitational potential, to be honest. Complicated because it's got a half, complicated even more because it's got a squared. Same rules, dead easy, promise you. Let's arrange it for M, first of all. So once more, I'm going to keep saying this, don't start with M equals. You'll get everything completely horribly wrong. M is on top, leave it alone. What we've got to move is the half and the V squared. All right, so the first thing is, how the hell do we get rid of a half? Well, the opposite of halving something is doubling it or times it by 2. Or a way of looking at this would be actually, this is mv over 2. So it's divided by 2, you multiply by 2. The end result's the same. It really does just depend how you want to think about it. Some people would say, well, it's a half times m, so I divide by a half. That's absolutely fine. It's a bit of a messy way of writing it, but we're not doing maths. It doesn't matter as long as it works. The other way would be to multiply it by 2, exactly the same thing. If you're not convinced that multiplying by 2 and dividing by a half is the same thing, get a calculator out and try it. Right, the next one we've got to move is the v squared. Lots of people at this point go, okay, so I need to square root it. No, this is just a thing and it's a thing in a box, and we don't care what it is, we just need it out of the way. We pick the entire thing up, and we move the entire thing over this side. That just leaves m, and that's it. Dead easy. We don't square root anything to get to the m. We just need to move the v squared wholesale. Okay, let's imagine instead that we want to get to the v. This requires a slightly new step, but the same rules still apply. So we're not moving the e because the v squared is on top. It's everything else that has to move. So we do the same thing with the half. We have that same dance, divide by half, multiplied by 2, whatever you think. Then we've got to move the m. So it's multiplied by m. We just divide by m. And what we're left with on the right-hand side is v. Now, it sort of looks like it's on its own, but it's not, is it? You've got a squared there. What is the opposite of squaring something? Lots of people say things like divided by 2, but think about it really carefully. The opposite of squaring something is to square root it, isn't it? So almost we do the same thing we did with the half and the m. We pick up this 2, we chuck it over that side of the equals sign, and we do the opposite. Same rule applies. Again, this is not really good mathematical grounding, but it's a rule that's easy to grasp and it works most of the time. So what do? We get rid of that squared and we square root everything on the right-hand side. On the left-hand side. Got your formula. So I won't say dead easy, but it is relatively straightforward with a bit of practice. And once you've done it a couple of times, they're the only 2 rearrangements you can do for this equation. So once you've done them, you've sussed them. We also are going to meet the suvat equations, or equations of constant acceleration. These are complicated. I'm not going to go through every one of these in this video. It will drag on a little bit, but I will show you some of the key bits. So the problem with these is they've got multiple parts. All right, rearranging for u here is relatively straightforward. It's not on its own because I've got a plus at. We do the opposite. Plus becomes minus. Leave the v where it is. Don't write u equals. You get sick of me saying that, but believe me, people still always do. V equals, leave the u where it is, because now it's going to be on its own. All right, I need to make myself a little bit of space, perhaps, to do this. Take away the at, so pick up that whole at term. It doesn't matter if it's at, it's just a thing, a bit like v squared. Take it away. All right, things you want to be careful of here. That's not the same thing. Obviously, 1, it'll give you a different answer. And 2, the v's become negative. The v was not negative here. You're not allowed to just make it negative. So you do have to be careful when you're taking away and dividing that you do it in the right order. Okay, let's consider we need something that's in that at. Maybe we need a or we need t. Let's go with a, but we'd do exactly the same thing if we needed t. So now what we need to get rid of, keep the a where it is, it's on top, but we need to get rid of the t and we need to get rid of the u. The trick here is getting used to knowing what order to do things in. So the way I would look at this is a little bit like tidying up or chipping things off to get, you want to clean up the a and it's got stuff around it. What's the easiest thing to move? What's the kind of most straightforward thing, the thing that's less well attached to the a that you could just easily brush off? Well, I don't know, in my logic, that's the u. Look, you can move the t first, but what happens if you move the t first is it gets complicated, you've not helped yourself. So doing it in the wrong order doesn't matter so much, but the chances are you'll get the maths wrong that follows, so try get it in the right order. Okay, this is u plus at, we want to get rid of the u, so it is added, we want it to do the opposite, it becomes take away. V, take away the u. Don't get that the wrong way around. Now we've got something a bit more familiar. I want the a, I've got a times t. Now it's a little bit easier, I want to get rid of the t, so I divide by it. So we take everything and divide by it. Whatever's there gets divided by t. Doesn't matter if you've put it there, it was there to start with. So just be a little bit careful with that one. It does take a bit of practice, but that's most commonly where people go a bit wrong, is mucking that up. No great surprise. It's not easy when you've not done algebra for a little while to get that slightly wrong. If you did move the t first, you end up with v over t. But for reasons I won't go into, you also end up with u over t. This is where I really need to get into the maths of it, and that isn't really what we're here to do. But Just be careful is the bit of advice I'll give you. It may not be perfect, but it'll do us for now without doing a degree in maths. Okay, this one's tricky because it's got a bracket. So the bracket is kind of like a box, and the way I think of it is you can't get into the box until you've tidied the stuff around it away. Also, the box is quite handy because if you don't need anything in the box, you can pick up the entire box and move it. I'll show you this in two examples. We'll go for T and we'll go for U. So firstly, T. T is on top. So what do we need to move? We need to move the U and the V, the bracket or the box, and we need to move the 2. So we have the S, don't touch it, leave it alone. Divided by 2 on this side means multiplied by 2 on the other. So we could go times 2. It's a bit neater to write that as 2S, but S times 2 is exactly the same thing, and we're not too fussy. We also now need to shift the box, so let's just see what we've got. I don't need anything in that bracket. I want T, so don't bother taking away U's and V's. It's going to go horribly wrong. Just pick up the box and shift it. Pick up the whole bracket, move the whole bracket, and it was bracket times T, so now you divide by bracket. Easy. Again, notice we didn't start with T equals. I will actually stop saying that now, but if you started with T equals, give yourself a slap. All right, let's have a look at the opposite one. This is a little bit tricky. If we wanted something that was inside of that bracket, for example, let's go with the U. The V would be the same thing. Okay, so again, it's on top, although this is going to be messy. We need to open this bracket up, and before I can do that, I need to shift all the stuff that's around it. Yeah, rearranging equations for me is like tidying the garage. So again, we multiply by the 2, and that gives us U plus V times T. Before I can open this bracket up, I need to shift the T out of the way. I don't know, think of it like I need to move the trainers that are sat on top of the box before I can open it. It's bracket times T, so obviously I divide by T when I take it over to the other side. And now I don't need the box. I've just got 2 things. A bracket or not a bracket makes no difference at all here. So really what I've just got is 2S equals U plus V. I want the U. How do I get rid of a plus V? I take it away. Again, just be a little careful. You've got a thing that might be 2S over T. It doesn't matter. It's a thing, and you're taking away V to leave the U behind. Don't go writing things like the divide by T happened before the U was there, so don't involve it. That's wrong. Again, little nuances, but you pick these up with practice. Okay, next equation. Lots of squares in this one, but actually, between everything we've done, you should know how to deal with this now. Let's say that I want the U. All right, first thing, I've got to get rid of that. It's a big chunk of stuff. Doesn't matter what it is. Take it away. Now I just need the U, so what did we do before? Easy. Now I know that you know that squares of a square root cancel out, but you cannot do this. Sorry. You cannot do this. Doesn't work. Not allowed. Again, I can explain to you why, but, you know, not on this video. Okay, let's imagine that we want the S. Let's make ourselves a bit of space. So this time I've got to get rid of this thing now. So we take it away. If I took it away, if I started doing dividing by things first, it would get complicated, a little bit like the last one. So now I can divide by the 2 and the A. So I pick them up and I move them over to the other side. Sorted. All right, last one. This one's a bit nasty. There's also one rearrangement you can't do. You cannot rearrange this equation for T equals. You have to use something called the quadratic equation to solve it. The only time you can is if U is 0. So let's just say U is 0 and I want T. In this case, the equation simplifies because U times T, if U is 0, is just 0, so it disappears. Now you can rearrange this for T squared. Dead easily. 2S over A equals t squared. So t would be the square root of all that. Again, I'm going quite quickly now because you've done these, so you can do these for yourself, but I'm telling you what they should be. Make sure you can do them. Let's rearrange this for a. Nothing different to what we've already done this one. I want a. So the first thing I need to get rid of is this. Then I can break into this box and deal with it. So it's add ut, so we take away ut. And now I can break into this box and get hold of the a. So I deal with the half the same way we did before. Multiply everything by 2. Everything. That does mean we have to do that. Or that. You can't just do that. It's not the same thing. Incidentally, if you can hear snoring in the background, it is my dog, and this is exactly the right response to learning algebra. But anyway, we've multiplied by the 2, so now we've just got a t squared left. I want the a, so it's the t squared. Square root it? No, of course you don't. We don't want the t. We just want it out the way. So pick the whole t squared up, boom, and shift it over the other side. If it was anything else, we'd just divide by it. That's exactly what we do. So there's no square roots or anything in this one. Okay, so there's other things that you can rearrange all of these equations for. I would sit and practice them all. In fact, this is quite often something we'll do in a tutorial as well. But it's something you're not going to get good at until you've done them 3 or 4 times. So practice really is important here. I know this can be really, really boring. But if you can master these, then you can rearrange anything. And when you go on to your degree, if there are other equations that you meet, you'll be able to rearrange any of the equations you meet if you can handle these. You won't ever have to rearrange something more complicated than these equations. So practice them now, crack it now, overcome the fear of algebra, and you will honestly be able to do anything. Not a triangle in sight.